problem, we have a box with a certain mass sliding along the floor being pulled by a horizontal force with some friction. And we want to know what is the work done by various different forces in this problem. So the general formula for work is force times distance. So we're given what the distance is in all of the questions about the work, and we'll need to find the force. And the forces that we specifically care about are the pulling force, the frictional force, and the net force. So the first thing to discuss with this problem is that we're told crucially that the box has a constant velocity. And this clues us in that since F equals ma and v does not change, dv dt is equal to a is equal to 0, the net force is also 0. And so right off the bat, we know that the answer to this last question is going to be 0 joules. But we also need to know this in order to solve for the actual value of the forces in this problem. So we'll draw a free body diagram of the box. So it'll of course have some gravitational force. There will be some normal force up that's equal to the gravitational force, the pulling force, and the frictional force opposing the motion. And we know that the gravitational force generally is mass times acceleration due to gravity, and that this is going to be equal in magnitude to the normal force. We know that the formula for kinetic frictional force is our coefficient of kinetic friction, mu, times the normal force, which we can alternatively substitute in here as mu mg. And we know that since the net force on this block is 0, the magnitude of the frictional force must be equal to the magnitude of the pulling force. So these also must be equal. So this is also equal to F. So knowing that, we can plug in our values for mu, m, and g here and plug all that into our equation for the work. So for the pulling force, the work is going to be mu m g d. And we want to be careful about the sign here. This is a dot product. So if the vectors are both pointing in the same direction, then it'll be positive, but pointed in opposite directions, then the result will be negative. Since the pulling force is in the direction of motion, so we're pulling the box 0.71 meters in that direction, the result for this force is going, for the work for the pulling force is going to be positive. So if we plug in all those numbers into a calculator, we'll get mu is 0.25 times m is 3.72 times g is 9.8 meters per second squared times d is 0.71 meters. And that comes out to about 6.47 joules. So that's for this one, 6.47 joules. Now, what about the frictional force? Well, if you notice, the frictional force is the same as the pulling force in magnitude, but in the opposite direction. So the overall magnitude of the work done by the frictional force is actually going to be the same as the work done by this pulling force. It's just that since the frictional force is pointed, say, that way, and the box is traveling that way, we're going to get a negative value here. So frictional force is going to be, work done by the frictional force is going to be negative 6.47 joules. And that's the solution to this problem.